All right, we're going to discuss today 3 theorems involving proportions. Okay, I got something funny. Wait. Nah, that was wrong. Still got nothing funny about similarity and proportions. But hey, I tried. Nah, I really didn't. I'm sorry. No, I'm really not. Anyway, let's go on. So, when a triangle contains a line that is parallel to one of its sides, the two triangles formed can be proven similar by angle-angle similarity. Since the triangles are similar, the sides are proportional. So theorem 65, if a line is parallel to one side of a triangle and intersects the other two sides, then it divides those two sides proportionally. So if segment BE is parallel to segment CD, then AB over BC is equal to AE over ED. Now, keep this in mind. Because of means extremes product theorem and the ability to switch positions, we can also go that say that AB over AE is equal to BC over ED. So two ways of looking at this. We can compare them this way. We can set up proportions that'll work. Or we can set them up this way and we'll have proportions that work. And this is called the side splitter theorem. Okay, so if 3 or more parallel lines intersect 2 transversals, then they cut off the transversals proportionally. The thing that you want to kind of consider, let's say this is line X here. So here's line X and here's line Y. We can see that sooner or later they're going to intersect and they'll form a triangle. And since the segments are all parallel, well, then we go back to the side splitter theorem and we can use that application then. So what we can basically do is derive this from the side splitter theorem, and by saying that if the lines are parallel, then they cut off the transversal proportionally. Okay, so now if a ray bisects an angle of a triangle, it divides the opposite side into 2 segments that are proportional to the lengths of the other 2 sides. So if segment JM is an angle bisector of triangle JKL, then KM over LM is equal to KJ over LJ. So again, because of equivalent proportions and with means extremes product, basically we can say the same thing. We can take and interchange these two here. So we can set this up so that we can compare these two values here and these two values here, or we can also do the comparison between these two values here and these two values here. Okay, doesn't matter, you're still using the same concepts. And this is called the angle bisector theorem. So here's some problems as shown. Line BE is parallel to line CD in the lengths that are shown. First, we want to find ED. Well, we know that since the relationship between these two is 2 to 4, then ED over 7 equals 2 to 4, right? So we can go back and say that we can even simplify this further and say 1/2, because 1/2 is equal to 2/4. So if we go with that, now we just cross multiply and divide. So 2 times ED equals 7. So ED is equal to 7/2, or 3 1/2. All right, we also know that now there's a secondary situation. We want to find CD. So we do need to find out that this whole length is 6. So the relationships between the two triangles, the scale factor is 4 to 6, right? So you may want to put that over here. Scale factor equals 4 to 6, which is equal to 2/3. The scale factor is always one of those things that you can use between two similar triangles. So now we can set this up as, we'll go smaller to larger because that's what we have here, right, on the scale factor, that we're going to go with 2 over 3 equals 6 over CD. So we can cross multiply now. So 2 times CD equals 18. CD is equal to 9. Okay. A is parallel to B, is parallel to C, is parallel to D. Lengths are shown. KP, this entire length, is equal to 24. Find KM. All right, so this is a ratio problem, and it's not very hard. Basically, you're going to take and say that this is 5x here, and this is 2 times x here, and this is 8 times x. And now we can just take that and add those together to equal 24. So we've got 5x plus 2x plus 8x equals 24. So we end up with 15x equals 24. So x is equal to 24/15, but that's got to be reduced. So the greatest common factor between 24 and 15 is 3. So that becomes 8/5, right? Which is, or 1 3/5 is x. Now, we are trying to find Km. So we want to do this here is we want to say 5 times, so Km we can say equals 5 times 8/5. Right? We'll keep it as an improper. That's easier way to solve. These cancel. So Km equals 8. All right, so angle RBS is congruent to angle SVT. So this is congruent to this. The lengths are shown. We want to find ST. Well, the easiest thing to do, we're going to go and we're going to compare between these, right? Those ratios have to be similar, right, or equal. So we know that 4 over 8 is going to equal x over 10. And so we can cross multiply and end up with 8x equals 40. So x equals 5. We can plug that into this here to double check if you wish. So let's go ahead and do that. So VR has a length of 8 and VT has a length of 10. And then we would say that RS, which is 4, has to be equal to TS would be equal to 5. And this is true. So we confirmed it with that. All right, here's a little proof that we're going to use to prove that Wx over Xa equals Wa over Az. So they're going to be using some of this. So based upon the given, we know that Wx over Xy equals Wa over Az. So what they're saying is these two comparisons here gave us this here, right? So this is this part right here. Basically on the given, angle XAY is, so these two angles are congruent, right? So we know that this is congruent to this. So now we can take this information, get to this, and now we can substitute. The substitution problems, by the way, give students the hardest time. They look at this information here and they don't know how to get from here. They've got to connect for this to this. Here we have DH is parallel to BC, and we have line HF parallel to line BG. So again, we're going to use side splitter theorem, and we get CD over DE, right? So these two, and I'm going to do this way so that this is a little more. So I'm going to do this over this, and that's going to be equal to DE over H. Oh, excuse me. Whoa, my mistake. Wrong part there. That's going to be equal to this over this, BH over HE. We're going to have the same situation, which shows us that BH over H, excuse me, HF is parallel to BG, right? So we're doing this second triangle. So what we're going to end up with here is comparing BH over HE. So these two are going to be equal to these two. So now by transitive property, okay, you can basically see we're using the same segment right here. We're going to have CD over DE equals GF over FE.
That's all, folks.
My grandchildren are loud.